Hello everyone. Welcome to today's session on operating systems for class 10 information technology. Let's go kick things off with a simple question. What exactly is an operating system? To put it simply, it is the main system software that acts as a bridge between you and your computer's hardware. Without an operating system, your computer would be like a car without a driver. It just won't work. It constantly keeps an eye on and manages important resources like where your files are stored and how much memory is available. Think of it like the headmaster of a school. They don't teach every subject, but they make sure classrooms are set up nicely, schedules are followed, and resources are easily available so that everyone can learn and work well. The OS does a similar job inside your computer. Now, let's go deeper into our definition. The word intermediary is key. Computer hardware talks in electrical signals, binary code, and physical voltages, while we view humans prefer to speak in natural languages and do things visually or intuitively. The operating system acts as a translator, turning what we do into instructions for the hardware and then giving us the results in a way that easy to understand. Turns a double click into disk read and a keyboard tap into characters on the screen. This means we don't have to write complicated code to interact with your computer storage or memory. Let's look at the main task that every operating system does. First up, file management. When you save a document, download an image, or create a folder, the OS figures out where to put the data on your hard drive or SSD. It keeps a map inside to help you find your files quickly. Second, memory management. Every program you open needs some space in your system's RAM. The OS gives your web browser, text editor, and other program specific blocks of RAM and make sure to free up space when you close them to keep your computer running smoothly. The third function is device management. When you use your computer, it connects with all sort of gadgets like keyboard, mic, printers, monitors and headphones. Each of these devices talks to the computer using special software called device drivers. The operating system acts as a central control center, making sure these drivers work together so your printer gets the right document data without any problems. The fourth function is program execution and scheduling. When you open an app, the operating system loads its code from storage into memory, sends it to the main processor, and set up priorities so that multiple apps can run smoothly without freezing the computer. Operating systems are tailored to fit the hardware and what the user needs. We usually put them into three main groups. Number one, interface type. This tells us how you interact with the machine, like typing commands or using a screen. Number two, number of users and task capacity. This shows whether the OS is for one person or for many users and tasks. Number three, processing mechanics. This explains how the kernel manages the execution instructions. Imagine how a company sorts out its work. Some departments handle customer service, that is interface. Some focus on single accounts users, and some do tasks individually or in teams. That is processing. First one, CUI, command line interface. You have to type in the exact commands. It is quicker for those who are really good at it, but it can be tricky for new users. Second one, graphical user interface. It uses icons, menus, and windows. It is easy to understand and great for beginners. Modern OS like Windows 11 and Mac OS use GUI as the default way to use the computer. Let's take a look at the two main ways we interact with our computer. The first is the character user interface CUI, also known as a command line interface CLI. Instead, CUI environment, you will see a plain text only prompt screen. There are no colorful folder icons, wallpapers, or mouse cursor support. To do simple things like creating a directory or moving a file, you have to type exact case sensitive strings. Even a tiny spelling error can cause the program to crash. While this might seem a bit scary for those who are not used to it, it is incredibly powerful and fast for technical people and system administrators because it uses very little memory. On the other hand, the GUI or graphical user interface is a visual environment that most people use on laptops and smartphones today. Instead of having to remember complicated text code combinations, a GUI shows you the operating environment in a clear and easy to understand way with things like icons, windows, drop down menus, and action buttons. It also lets you use pointing controls like optical mic, laptop trackpads, or multi touch screens, which makes it easy for beginners to use. Now, let's consider single user, single task environment. This environment only let one person log in and use one program at a time. For example, if you are writing, you cannot play music or download files in the background. The computer focuses on the single program until it is finished. This was how things worked in older MS-DOS systems. It is simple and uses basic operating logic, but it is not very efficient for what we need today, where we expect computers to be able to do things in the background at the same time. In our modern world, we are used to single user multitasking setups on desktops and laptops. Imagine logging in to your own space and being able to edit a research paper, crunch database numbers, stream high definition audio, and even run an antivirus scan all at once. How does a single processor manage this? It's all thanks to CPU time sharing. The operating system quickly divides CPU time into tiny bits of a second, giving each application a little slice of the pie. It switches back and forth so fast that it seems like everything is happening at the same time. Think Windows, Mac OS, and desktop versions Linux like Ubuntu. Multi-user operating systems let multiple people use the same system at the same time, each with their own session and resources. Shared resources like the CPU memory and storage are shared fairly among all users. Each user has their own account with specific permissions and privacy settings. Examples include Unix, Linux servers, and Windows Server, which are used in schools, offices, and data centers. Multi user architectures are designed to handle a huge number of users, making them perfect for a mainframe grids, cloud computing nodes, and heavy web servers. This OS allows dozens, hundreds, or even thousands of separate users to connect to a single massive computer center at the same time. Each user logs into their own isolated user interface session with personal account permissions and privacy controls. The underlying OS kernel manages and allocates shared physical assets like CPU cycles, RAM space, and hardware storage blocks, ensuring fair performance and preventing any single session from crashing or snooping on another user's work. These are used in Unix, Linux server clusters, and Windows Server system in data centers, school, computer networks, and enterprises offices. Uni-processing versus multi-processing. Processing power classification. Operating systems are also classified by how much CPU they use. Modern computers and servers almost always use multiprocessing to run faster. Uniprocessing uses one CPU and can only do one thing at a time. It is easier to step up first but not as fast. Multiprocessing uses several CPUs and can run tasks at the same time, which makes it faster and more efficient. OS classification at a glance processing users and task interface. You can describe every operating system using these three levels of classification. For example, Windows 11 is a GUI based single user multitasking multiprocessing OS. Let's take a look at our final technical classification metric, processing. This metric shows how software coordinate instructions across physical silicon processors chips. In the past, systems used uniprocessing architecture, which meant they had just one CPU chip on the main board. This limited them to processing one instruction path at a time, which could cause delays for slower tasks. Nowadays, computers use multiprocessing operating systems that spread and balance workloads across two or more physical CPU units or multiprocessing cores. This allows for true hardware parallel processing. So, one CPU can handle video compression while another processes a database search quick query with any lag. This really boosts processing speed, throughput, and system reliability. You can classify even every operating system using these three matrices together. For instance, the Windows 11 platform on your lab desktop is a GUI based single user multitasking multiprocessing operating system. Quick quiz, test your knowledge. Let's see how well you understand the main ideas behind operating systems with this fun self assessment quiz.